I hope so. All right. Today you are going to be graphing quadratic functions. Graphing quadratic functions. All right. And the graph of a quadratic is called a parabola. So you're going to be graphing equations today that look like the function of x is equal to 1/2 of x squared. Now, there's something that's called vertex form of a quadratic. And vertex form of a quadratic is the function of x is equal to a times x minus h squared plus k. And the axis of symmetry is at x is equal to h and the vertex is at the point hk. So what that means is this is the shape of a parabola. All right, basic shape of a parabola. This point right here, in this case, it's at the bottom. All right, this is your vertex. The vertex of a parabola can either be at the bottom or at the top. In this case, it's at the bottom. Then the line that splits, the vertical line that splits this graph or this parabola right in half, is called the axis of symmetry. And since it's a vertical line, it's always going to be x is equal to whatever the h value is, or the opposite of the h value, when the equation is written in that vertex form. Okay? Now, as we get going here, this will all make a lot more sense. So, the first thing that you're going to be doing today is you're going to be graphing a function. So, let's just say that you're asked to graph the function of x is equal to 1/2 x squared. All right? And f of x equals 1/2 of x squared is a simpler way of writing the function of x is equal to, in this case, our a would be the 1/2 times x minus 0 squared plus 0. F of x equals 1/2 x squared is, or written in vertex form, is f of x equals 1/2 times x minus 0 squared plus 0. So if you identify the axis of symmetry of this graph, it's at x is equal to h, all right? And in this case, our h is 0. So our axis of symmetry is going to be at x equals 0. And our vertex will be at 0, 0. So here's how you graph f of x equals 1/2 x squared. All right? You always want to identify your axis of symmetry first, and you want to identify your vertex. So then, what we do is we build a table of values, okay? So we've got our inputs, which is our x's, and we've got our outputs, which is our f of x. We're going to put in we're going to have 5 different coordinates. The vertex is always going to be your middle coordinate. So right here, we're just going to go 0, 0. We know that when we input a 0, we're going to get a 0 out because that's the vertex. Then you want to pick 2 inputs to the right of 0, or to the right of the x at the vertex, and 2 inputs to the left of the x at the vertex. So if you had a coordinate plane over here, here's our f axis and our f of x axis. If we plot this vertex, it's right here at 0, 0. Now we want to pick 2 units, or we want to pick 2 inputs to the right of 0 on the x-axis. What you want to pick when you have a fraction as your a is multiples of the denominator. That way you'll always get whole number outputs. So if we pick, we've got 0, 0 as an input. If we pick another x value of 2 and then 4, okay, so we picked a 2 to the right and then a 4 to the right, because those are multiples of this denominator. Whichever values you pick to the right of the x at the vertex, you pick the same but negative on the left. So we're going to pick a -2 and a -4. So now you complete your table of values, okay? If we substitute a 4 into this equation for x, what is 4 squared? 4 squared is 16 times 1/2 is 8. 2 squared is 4 times 1/2 is 2. So when you're squaring things, if you square a 2, you get a 4. Well, if you square a -2, you also get a +4. And half of that 4 is 2. And if you square a -4, you get a -6, or you get a +16, and half of 16 is 8. So there's your table of values. And then you plot those table of values. Okay? So we've already got 0, 0 plotted. We're going to plot 2, 2. So which is 2, 2. And then we're going to plot 4, 8. So 4 and then 2, 4, 6, 8. Now, a parabola is symmetrical. So wherever you plot these 2 points to the right of this axis of symmetry, you plot to the left. So we can just go 2 to the left, or you can just go to -2, 2, and then -4, 8 would be right up here. Now, when you start graphing these things, they're going to look funny at first sometimes. You're just trying to get a U-shaped curve down here at the bottom of this parabola. It doesn't have to be perfect, but just understand that it's not a V. So you want something along the bottom that looks like this. And then you can just continue the graph on either side of this function of x axis. Does that make sense to anybody? Okay, so let's look at a couple more of these. Let's graph f of x is equal to 3x squared. All right, this is in the same format as this previous equation. So if we wrote this in vertex form, it would be the function of x is equal to 3 times x minus 0 squared plus 0. So our axis of symmetry would be at x is equal to 0, and our vertex is going to be 0, 0 again. When these change, we're going to talk about that tomorrow. Your equation will be in a different form. All right, the look of this equation over here might be 3x squared plus 1. All right, it might be 3x squared minus 7. All right, and then that would change this k out here. Instead of being a 0, it would be a 7. Or you'll actually see it in vertex form where the number in the parentheses with the x is other than 0. All right, so the next step was to build a table of values. So you got your inputs, which are your x's, your outputs are your function of x. Vertex goes in the middle, so the vertex is at 0, 0. Now, if this a is a whole number, then just pick a 1 and a 2 as your other inputs, and then a -1 and a -2. Then substitute the 1 for the x, and 1 squared is 1 times 3 is 3. And 2 squared is 4 times 3 is 12. Just like the last table of values, since we're squaring the x, the outputs are going to be the same. So at -1, we've got a 3, and at -2, we've got a 12. So when you graph this, just try to make room for your y's, or just understand that your y's are pretty high up on the y-axis. So everything in this graph is happening down here at 0, 0, and it's happening above the x-axis. So this is our x-axis and our function of x-axis. So we got the point 1, 3, and then 2 would be up here at 12 somewhere. And then you can take those 2 points and just reflect them across the f of x axis. So -1, 3, and -2, 12. And then just understand that as this number in front of the x squared gets bigger, this graph gets taller. So you've got something that looks like this. Any questions? All right, then your practice for today is going to be on page 199. Problems 7 through 14. And then you've got 8 Alex topics this week. And just give me 1 second, I'll get that page put up there for you. Take the pass.